Okay, hello to Honors Algebra 2 students, and I want to welcome Mr. Patterson's class. His students might be watching this video today. This video is for Tuesday, 3/24, March 24th, and we're going to use a section out of our note packet from section 13.5 on the law of sines, and we also will be using a section from 13.6 law of cosines. Okay. And by the way, you students from Mr. Patterson's class, I'm not so sure he's taking a shower every day, so when we get back, you might want to ask him that. Okay, so today we are going to look at finding the area of triangles, of any triangle. Does not necessarily have to be a right triangle that we would use 1/2 base times height on. Okay, we have two ways to do that. First way is when we are given any combination of two sides and the included angle. So that means we're dealing with a side angle side situation. Our angle is made up or in between the two sides. Okay, when that happens, we simply have a formula that we can use, and you can see there's three variations of it down here in your notes. But what you want to recognize on each one is that the angle you take the sine of is always between the two sides. So up here, angle A is between sides B and C. So down here we use side B and C when we use sine of angle A. And then the same thing happens for each one of these other formulas. So the easy way to remember this, and this works for any triangle, if you have side angle side information, how you find the area of any triangle, you just simply do 1/2 of a side times the side times the sine of the angle that is between those two sides. Just remember your formula that way. It's much easier than trying to remember three different formulas. Okay, so here's our first example. And if we look at our given information, now you might be able to look at this and say, I'm given angle C and I'm given angle A and B. That means angle C is between those two. So you might be able to tell that it's a side angle side by looking at the information that way. Or you can always sketch your triangle like I have here to verify in front of your eyes that you have a side angle side setup. So we have our side angle side setup. Here's what it looks like when we plug into our formula: 1/2 6 times 9 times the sine of 40. Punch that in our calculator, we get 17.4. And remember, it's an area problem, so it is units squared. Okay, so why don't you try number 8, pause the video, and I'll come back with the work. Okay, for example 8 out of our notes, we have an obtuse triangle, an obtuse angle, which makes an obtuse triangle. Angle B is between sides A and C. Here's my drawing, and again, you don't have to be super accurate. Notice I did not draw angle B as an obtuse. I simply sketched the drawing so I see where everything is, and that I kind of visually confirm that I have side angle side. And we do, so we plug into our formula: 1/2 12 times 7 times the sine of 120, or 12 times 7 times the sine of 120, then divide by 2. I get 36.4 units squared. I do want to point out one thing about the area formula you're most familiar with. Area equals 1/2 base times height in a right triangle. This is a side angle side setup like what we just did, but our angle is 90 degrees. So the 1/2 base times height, if we plug this into our today's form, it'd be 1/2 base times height times the sine of 90. But the sine of 90 is always equal to 1. So we don't have to worry about multiplying by the sine of 90. So that's why in geometry you only learned 1/2 base times height. That was because the sine of 90 was always equal to 1. Okay, our second area formula today comes out of 13.6. So you need to flip forward to 13.6, look for problem number 7 at the end of it. And this is called Heron's formula. Okay, now this is used for side, when you're given side information. So we can actually find the area of a triangle even though we do not know any angles that we're given. Here's our formula for that. Its area equals a big square root of S times S minus A times S minus B times S minus C. What is that S? S is a semi-perimeter. So we just simply add all of our sides together and divide by 2. That's how you find semi-perimeter. Okay, so on example number 7 down here, we have 3 sides. A is 6, B is 4, C is 5. So our semi-perimeter would be 7.5. So we find our semi-perimeter of 7.5, and then let's look at the formula here real quick. So what do we have in our formula? We have 4 numbers in our formula, or underneath that square root. We have the semi-perimeter, 7.5, right there. And then we just simply take that 7.5 and we subtract each of our 3 sides. So 7.5 minus 6, 7.5 minus 4, 7.5 minus 5. Then we multiply all that together and we square root it, and that answer is our area, 9.9 units squared. So those are your 2 area formulas for side angle side situation and side situation. Your homework for today is out of the textbook. Here they are, page 804, 3 problems, 37, 39, 40, and page 811, 39, 40, 41. Hope everybody's doing well. Keep your spirits up, help out your mom and dad, and do what you can. We'll see you sometime soon.